that's a nice area to live.
Oh, yeah. South Minneapolis is a nice area. South Minneapolis is a nice area.
All right, well, I think most folks are here. We're going to get this kicked off. Hi, everybody. Thanks for coming out. I'm Lloyd Lentz, one of the organizers of GDG Twin Cities. We have a couple other organizers here tonight. In the back is Patrick in the red flannel and Jeff in the bow tie. Who doesn't like a bow tie? For whom is this your first GDG meetup? About half. See, I'm always impressed with that. And folks find this on Meetup, or how'd you hear about tonight's? Meetup? Go Meetup. It's great. Well, thanks for coming out tonight. GDG is a Google developer group. It started kind of as somebody's side project at Google as a way to get the community involved and kind of meet other peers who are working on projects that other folks might be working on in different cities throughout the country, and that's grown from 5 or 10 groups around the country to about 300 groups worldwide. It's now a full-fledged kind of effort within Google to involve the community, and it's pretty exciting. So we meet once a month. We'd love to see you guys if this is your first event. We'd love to see you at any of our other meetups. We usually meet the first Tuesday. This is the second Tuesday because last Tuesday was a holiday. And we talk about we have someone usually present on different topics involving Google developer tools. Tonight we have an expert, somebody who works actually for Google. Well, I didn't put the air quotes in physically, but we often have speakers who, we like to say that we're a group that is for the community, run by the community. Everybody who talks is kind of a volunteer. Some of the best talks we have are folks who are just learning a topic, and that kind of beginner's mindset is a great place to give a talk. So keep that in mind. If you're learning something new and would be interested or willing to give a talk, we're always looking for good presenters. If you have something in mind, you can talk to me or Jeff or Patrick. Paul's not here tonight, or Emily, our other two organizers. Let's see, so that's a little bit about GDG. Our big event next month, we're not having a regular meetup, but annually we have a big event called DevFest. So the February 2nd, it's a Saturday, it's all day. There'll probably be 600 people in attendance is what we're shooting for this year. We have about 50-some speakers. This year it'll be at the University of St. Thomas, where we've had it the last number of years. But this year we're shifting. Who made it last year? A handful of folks. So I don't have to explain too much different, but one thing I think that is going to be great is the venue this year will be just in the School of Law. So the University of St. Thomas, the downtown campus, the School of Law has this beautiful kind of 4-story glass atrium. Our keynote is coming from Amsterdam, Netherlands, somewhere. Netherlands. We're really looking forward to that. So we've got a great keynote. We've got a ton of great content. We're going to be posting the schedule this week on devfest.mn. Early bird tickets, I think, are done, but it's a really great event. Jeff, are we still looking for volunteers?
Yes, we are. We've got 19 volunteers so far, and we could use a few more. So, I'll get you the link to sign up to be a volunteer. You get it for free, you get a t-shirt, you get free lunch. But if you pay for a ticket, you also get a t-shirt.
You also, right.
What are the dates?
It's just February 2nd. One day. Yeah. So that'll be starting in the morning. We'll have the keynote and then talks throughout the day. And then the after party will actually be in the same place. We'll have light appetizers and such. So, anything else that we should cover for housekeeping? No?
Oh.
Yep.
We're lining up some Google speakers for the next meetup, the one in March. So we'll probably have 2 different Google speakers here. and 3 kind of a fun thing. And,
Yeah, and we'll be back, so in March we'll be back here at Agosto. Do you know more of the details on that?
Wesley Chun, the guy who wrote one of the Python books, and I don't know who his colleague is.
Right.
So
Yeah.
we're going to be down for a different conference that's part of ACM, and then they'll stick around for us.
That'd be great. And so we announce all of our meetups and all of the kind of general announcements on Meetup. So if you join our group on Meetup, then you'll get all of these announcements as well. That's about all I have. I'm going to just hand over the floor to Dave and let him introduce the talk.
All right.
Thanks.
Is this mic on? Can you hear out there or?
Great.
All right, now I'm recording. I had to press the big red button. All right, so I'm going to start with a little bit of an icebreaker. No, we're not going to have to get up and do any calisthenics or anything like that. I wanted to get an idea of people's exposure to Internet of Things and IoT. So, broadly, who knows what IoT stands for? Okay, that's good. All right, who has played with IoT products or frameworks? Okay, and has anyone used Google's IoT frameworks or tools? A couple, 2, 3, 4, all right. All right, so probably a good topic then to give you guys some exposure. So by way of introduction, my name is Dave Anderson and I work for Google Cloud. And I'm actually local here to Minneapolis, and I would like my 2 colleagues from Google to also raise their hands, Andrew Ripka and Andrew Griskowiak. So we work in the cloud organization, and we are known as customer engineers. So our job is to go out to customers, clients, people that are utilizing or thinking about utilizing Google Cloud technologies and help them understand the tech better and maybe implement the tech in their environments. So Paul, one of the organizers, asked if anyone from our office would be interested, and of course selfishly I said, sure, you contacted me, I'll be a speaker. So I thought I'd come and talk about IoT, the Google Cloud IoT platform. And I promise I kept the marketing spiel out of it. I'm not going to try and sell you anything, I'm just going to talk about the technology tonight. So Google's original vision, or our view of IoT, was device, gateway, cloud, right? And really, it really is about getting your data somewhere, right? These devices are generating tons and tons of data, and you need it to go somewhere. So why not just put it in the cloud? Now, the thing about it is, Google has always been cloud first from the time that we launched our, first search engine. It was very much a software as a service out on the web, and everything that we've done has been very cloud focused. And that was kind of the way that we went to market originally with IoT. So we had a product in the Google Cloud portfolio called IoT Core. And basically what we looked at it, pretty simple use cases, right? You have a device down here. The device would connect to IoT Core directly through an API platform that we built over MQTT or HTTP. And then basically that would give you access into the entire cloud ecosystem. Can anyone tell me what the problem here might be?
The devices might not have access to the internet directly.
Exactly. So the assumption here was that every device was going to have consistent Wi-Fi, right? And they could connect to the cloud or a cellular signal, but they would be able to connect to the cloud directly and get all that lovely cloud goodness that Google or Amazon or Microsoft were providing, right? So basically Google kind of stepped back and said, okay, based on the use cases that we've seen so far and some of the feedback that we've gotten from customers that are using it, there's obviously a need for more things here, right? There needs to be more capability actually where the devices live. And so we started to expand our offerings to allow for gateway devices to be on-premise, which could then be the entry point into IoT Core. So let me pause here. So I asked questions about IoT specifically and Google Cloud Platform. So who here has looked at other cloud services from Google?
Like Google Cloud, Firewall.
Yeah, Google Cloud. So like Compute Engine, BigQuery, any of those services that are in. So hands up again if you've played with anything. Okay, so that's pretty good. But yeah, so basically you look at the ecosystem and you've got Core that brings it in. We push that downstream or upstream, if you will, into other capabilities, which might be storage, it might be machine learning, it might be some sort of visualization tool. Those are all things that are well and good to use, but again, we were having issues with actually getting the data there. So, computing at the edge, really, and that's what I'm kind of focusing on tonight, is IoT Edge and some of our gateway capabilities as opposed to strictly IoT Core services. So some of the reasons why, and we already hit on one of them, so bandwidth, not necessarily having all the bandwidth that you need for all this data to be shunted back and forth. Connectivity, you might not have reliable signal. You may be out on a oil rig and there's one device that has a sat phone on it that can transmit data, but you've got 1,000 sensors that are picking up data. And so how do you make that work, right? The other thing is cost, right? Do you want to have all of these devices require Wi-Fi capability or cellular capability? You can make cheaper devices by making them simpler and easier to manufacture. And then privacy. It really comes down to, do you want to have to manage directly every single device that's in your fleet? Or would you like to be able to delegate some of that security and management down to a smaller number of devices than, say, 5 million, right? So, what are some of the other use cases that we have? So one of the big things about edge computing, and one of the things that Google is focusing on a lot, is machine learning at the edge. And so what we've done is we've created the ability to put our TensorFlow, which is our machine learning framework, which creates executable models that allow you to have inference. And basically what we're seeing is you get real world input in there, translates into raw data. You can take the raw data, convert it into semantic data, and you can draw inference off of that. So from this perspective, if you had a video camera in this room and it was taking a picture, you'd be able to do object identification of every person that's in this room and determine if your room occupancy was under fire code or not, right? And yeah.
Is that inference in the cloud or inference on the device?
It's actually on the device. So what we're able to do, and I'm gonna talk a little bit more about some of the technology that we have behind that. So, and I'm gonna demonstrate some IoT Edge capabilities from an alpha release of our product. But basically what we do is you're collecting this data, you then get it sent up to the cloud, whether it's from individual devices themselves or through a gateway, that can go up and train a machine learning model in the cloud. The model can be pushed back down to an individual device, and then those inferences are derived from the device on premise, as opposed to having to make that round trip to the cloud every time. And this is the thing that kind of gives us a little bit of an advantage out in the edge ML space. So what you're seeing here are TPUs. It's our TensorFlow processing units, and this is basically a penny. This is giving you basically the scope or the size of those TPU chips, which then goes into a board that can be mass produced from on a SOM or a SOC, which can become part of your IoT device. And, oh, yep.
Well, do those modules come as in some kind of development board form, a USB stick or something?
So the boards themselves, and Andrew, maybe you can, or Ripka, maybe you can comment on this as well. The The boards have been promised for a while. We're a little delayed in making them available. So we have this, there's going to be these AIY kits, and it's, you know, they're going to be development SOMs. So all of the devices that I'm using tonight are Raspberry Pis. So it's going to be similar to like a Raspberry Pi type device that comes with kind of some pre-built models already loaded onto the device so that you can experiment and start to see how you can utilize it. And the thing about it is, so I'm going to show you IoT Edge tonight, and the ML container is there. The Edge TPU is just there to accelerate the inference, not necessarily it's required to actually run TensorFlow Lite. Does that make sense?
Yeah, I guess so.
So the TLDR is what we announced at X is there's a variety of form factors, one of which is a dev board that is used for experimentation and prototyping. The idea being we're actually going to, these TPUs are going to be produced by hardware manufacturers, IoT companies that build things like gateways are going to throw these things, 3 or 4 of these things into like a gateway, and they can do IoT there if they choose to, or into the actual device. The other form factor we announced is an accelerator that will plug into a server, say in an edge location, that will allow you to have that function as your gateway. But we're in early access now, which what that means is if you are an IoT manufacturer or you are a large cloud customer with an interesting IoT use case, we're ready to post experiment.
Well, and I saw Intel actually introduce something along this line. It was some sort of, you know, machine learning compute engine that was in a USB stick.
Yep. Yeah, and typically that's going to be some sort of small form factor GPU from an Intel. So the TensorFlow processing unit is a purpose-built chip that Google designed specifically around running TensorFlow models. So it is from silicon up built for machine learning, right? So, and not to say that GPUs aren't there too, right? Because a lot of people are doing a lot of their ML workloads using GPUs as well. Yep.
Where's it manufactured?
Where is it manufactured? I don't know. Do you have any idea?
We're not at liberty to say.
Okay.
So I'm not sure if you guys heard this, you know, the Broadcom chips coming over, there's some vulnerabilities.
Yes.
So that's what people might be worried about.
These come from reputable manufacturers, but what we'll say is like in the cloud world and all of our, we have a program called Titan at Google that would have found that before somebody basically, we install a separately sourced chip onto all of our boards that watches what happens on the board, including that startup time and power consumption, so things that vary from spec we would notice. We highly recommend you implement something similar in terms of power management.
Yep. Any other questions?
We are, well, I will say, I didn't answer your question. We are validating that anything we give you as a TPU that ships from Google has been tested, and like we control the manufacturing chain, so we are.
And if there were a vulnerability,
Yeah.
it'd be
We don't test every one of them, but we randomly sample, so we can say that if there's something that's been inserted onto the chip in the manufacturing process, we are not going to ship those chips out. But ideally, we don't want to be in the hardware business. We have partners who are in the hardware business, but we're going to work with them to give them the same standards.
You're not doing anything like speculation behind the intelligence.
No, nobody thought we were going to have virtual machines when we designed that chip, so.
All right. So that is the end of quote unquote the lecture portion of tonight's program. So what I wanted to do is I wanted to go into some demos, and I wanted to show first what we're going to be looking at. So there are kind of two things. So one of the early, I believe it's in beta right now, is our IoT gateway. This is basically any sort of device, and in my case I'm using a Raspberry Pi, and essentially what it does is it has a gateway API that you can utilize to aggregate messages or data from multiple devices, and then that becomes the point by which you send. So you have a couple of different options here. One is, like if you have sensors, so think of things like Z-Wave or Zigbee, non-Wi-Fi, so you can have a mesh network here that is utilizing this as a controller in that thread or Zigbee network, and then basically it can take that and still you can push configuration changes back down to these devices through your gateway. So essentially you're still managing the entire fleet of devices, but you don't have to do it individually and have them connect individually. So again, you can send data up through the gateway and through that API that we provide, and then configuration information or control instructions, commands can come back from the cloud, changing the configuration based on maybe runtime metrics that you're collecting there. The other thing that you can do is you can actually have just a regular IoT device, so maybe another Raspberry Pi or something that you've manufactured yourself that does have a more complete dev stack on it and maybe has an MQTT API capability, which can push messages here, but again, you're passing it up through because maybe so everything that comes from something outside of Google Cloud that comes into our IoT Core is going to use a JSON Web Token as part of its security procedure to authenticate and authorize. So maybe this device doesn't have the libraries on it to create its own JOT, but you can actually bind this to this device, which does have that capability. So you still have secure communication up to the cloud through that gateway. Make sense so far? Yeah.
So you mentioned that on the bottom left, you
Yep.
have those devices which are non-smart kind of things. These are like non-Wi-Fi enabled, right?
Yep.
And how do they connect to this gateway device? Like, and how does the gateway device understand the kind of protocol or any kind of?
So I'm gonna talk about that in the next demo, which is gonna talk about a Z-Wave network that I've set up with an IoT Edge device. So this doesn't have to be, and that's one of the distinctions I wanna make sure I make. The IoT Edge, this gateway doesn't have to run the IoT Edge runtime environment. So there is a whole runtime environment that gets installed on an IoT Edge device. This gateway only has to have this gateway API that allows it to authenticate on behalf of other devices when it communicates with IoT Core. So this can be a simpler device, less compute intensive, less resources required to run this workload here. But again, you bring up a good point. When you're communicating with either like OpenThread or Z-Wave or Zigbee, you're gonna have to have some translation layer here, right? So you're either gonna have a custom built translator that understands the messages, the binary messages that are coming from any of the devices that are here. And again, if you're talking about a mesh network, that's a lot of things to do. So in my case, what I did is I picked out an open source platform, and I'm actually using Home Assistant. So they have a nice plug and play methodology that allows you to bring Z-Wave sensor devices in, get all of that data, which I was then able to translate and push back up into the cloud. So in this case, what I've got is I've got sensors around my home that are monitoring temperature, relative humidity, air quality, and things like that. And so that I can get that data over time, and I can start to see how things change in my house, and if I can optimize like energy usage, things like my HVAC system and stuff like that. So that's just one simple thing there. But again, there are open source libraries and frameworks that you can utilize that will translate this data for you to put it into a format that you can then send up to the cloud.
So is there any standard on the left-hand side which is kind of like, you mentioned Z-Wave, what is that Z-Wave?
So Z-Wave is one of the standards. It's in 802.15.4, and then Zigbee is the same thing, but it's using some different command structures there. And the same thing is true with OpenThread, or Thread mesh networks. OpenThread is one of the implementations of the Thread spec. And that's actually one that Google contributes to. And so a lot of our things that we're doing in terms of simple devices and non-Wi-Fi devices from an IoT perspective, we're really going after that thread model because it's very scalable and it has better range. Because again, all of these are mesh networks, and so there's only a certain amount of distance that can transpire between devices before you get to the next one. Yes?
Yeah, speaking of communication, on the other side,
Yep.
communicating to the cloud, if you have intermittent communication between the gateway and the cloud, what's the tolerance for the TPU in terms of doing that machine learning? Is there a certain amount of frequency that the device really needs to be, or the gateway really needs to be communicating to the cloud? If it was offline for a couple hours, that'd be okay. If it loses communication for a couple days.
Yeah. So if we're talking about TPU specifically in machine learning, so the thing that really the gateway device would be reliant on from a cloud connectivity perspective would be as more and more data goes up into the cloud, you can keep training your model to try and get better and better accuracy. And so the only thing that you might miss out on is you might have some training epochs that go by and you're not able to push it down to the device if it's offline, the new trained model. So that's really, but other than that, like if you're trying to do inference off data that's coming into that gateway device, it can all happen wherever that gateway device is. And really what you're risking there is like being able to send data up for more training or being able to get models back. The other thing that you can do is you can run localized messaging brokers here so that you can do more of a store and forward type thing so that you can have the ability to essentially wash over that limited connectivity, or if you have an outage, right? So then you can batch it up and send it up as a big load.
So you don't lose any data.
You wouldn't necessarily lose.
Delay in your machine learning.
Yep.
Because you don't have access to it. Okay.
Yeah, and you would need to design for that, right? It's not that it comes out of the box with that necessarily. You would need to design for that eventuality.
Okay, great.
Okay. Any other questions? All right, so I'm going to jump into our cloud console. So I'm sure most of you who said that you've played with Google Cloud have seen this particular screen before. This is the home screen, and you'll see that I have a little project here called Dr. Anderson Demo. That would be my initials and my last name, just in case you wanted to find out what the mystery was. But anyway, so this is just basically your kind of your one place to see kind of what's going on in your environment. You'll see that I've chalked up a whopping bill of $16.91 so far this month in my first 8 days of the month. So just really gonna have to talk to my manager about that soon. Make sure I'm still approved for that. All right, so what I want to talk about first is IoT Core. So let's go back to the front page. So basically the way that IoT Core looks at it is you have a registry. The registry is going to contain all of the information about the devices that are being managed by our IoT implementation. So in this case, I have my test registry, and you'll see that it's got, I'm supporting both MQTT and HTTP. It's in the US Central region, and I've got some pub sub topics that are there to receive telemetry data from my devices. So if I go in here, along this left side, you can see I've got the ability to look at registry details. I can look at the devices that are registered. I can look at any gateways that are registered. And then I can group devices. So again, if you're looking at thousands and thousands of devices, getting a list of just every device, on page after page. So we introduce groups to allow you to group things, whether by function or semantically, however you would want to categorize them. And then we also have monitoring capabilities that are there. So if we look at some of the details here, again, we talked about it. These are my pub sub topics. that I'm going to receive either device state or telemetry on. And then I've got 3 devices registered. One is my Edge test device. This is what is running the IoT Edge runtime. And then I have 2 pretty much dumb devices, IoT device 1 and IoT device 2. They are not communicating directly with IoT Core anymore. They're going through a gateway. So if I go over here, well, and let me jump into one of these. So what you'll see is you can see information about it. So I've got this long numeric string. This is actually the unique identifier from a Google Cloud infrastructure perspective, but I can obviously give it a name that's a little more recognizable to me, which I gave it the incredibly unique name of Edge Test Device 1. And you'll see what registry it's in, if it's part of any groups, and I can also go out and look at any logs that are associated with this particular device. And you'll see that there is a bunch of stuff out there. So again, what you'll see out here is heartbeats that are going back and forth between the cloud and the edge device to make sure that the device is active and able to be used. And if you drill into any of these, you can go in and look at the payloads that are there, any labels that are there. So this was a ping request or a publish request to the edge test device. But again, it's got a lot of data that you can take advantage of and see how your network is running. I'm going to go back into my device details. So some of the things you can see: heartbeat activity, telemetry received, device state received, any errors that have occurred, and you see I had my MQTT server went down. It's probably because I unplugged everything and brought it here for the presentation tonight. And then you'll also see here, every device has a public key that gets registered with the device. Sorry, I can't get that to pop up any higher. But basically, oops, you can go in there and we support different public key formats. You can see what the value is. You can see when my expiration date is. And in this case, I could enter it manually, or I can put a new one up there, upload a new one up there. So currently, Google allows you to keep multiple keys associated with this device that have different expiration dates so that you can actually have automatic key rotation for the devices. So if you wanted to rotate your keys in terms of being able to have better security on your devices, between your device and the cloud, we allow for automated key rotation there. Any questions on the device? Oh, and then you can also see that you can look at the different configuration and state information that's there. So this is going to be not much. So it's got, I mean, you can see some of the information, but a lot of it is very binary. In this case, it's talking about the fact that I pushed a container, a Docker image down to the device that had a function on it. But then the other thing is you can look at state information that's out there. And so this was the latest state information that was pushed up, which was sensor data, which has humidity, luminance, temperature, and ultraviolet radiation. So again, that's state information that's being pushed up. Yes?
Can you make it bigger?
Oh, sorry. Better?
Yeah.
All right. All right, yeah, so this is, and again, it's a binary, so MQTT is a protocol that was developed by IBM. It's binary, it's very compact, so it works really well for device communication. Is there a question?
Yeah, when you say container, does that mean you're pushing a container down into the Raspberry Pi?
Yes, so that's part of actually the second demo that I'm going to talk about. So our IoT Edge basically coordinates with our cloud build environment. So I can take like Node.js code, I can push it up to our cloud build product, which will then package everything up for me, create a Docker image for me based on a pre-selected image that I would utilize, and then it'll take that Docker container and through the registry and through knowing how to get to that device, it will stream that Docker container down and deploy it on the device itself. So again, you could run like a web application there. In my case, the Docker image is actually running a cloud function, which is a lot like AWS Lambda code snippet. And basically it's listening on a local MQTT broker on the device itself, and it will execute code when messages arrive on a certain topic in the MQTT broker.
That container contains a Google managed kernel,
Yes.
sort of like Android things.
Yep.
Okay.
Yep. Exactly. All right.
What version of the operating system is running on the Docker? Like, for example, Microsoft IoT, it runs Alpine.
Mm-hmm.
So for
Yep,
people,
it's Alpine.
It's also Alpine.
Yep. Yep. You're talking about in the container.
Yeah.
Yeah. Yep.
Is the Docker container required, or?
No. In this case, for the demo that I created, I wanted to use Cloud Functions. It's something that I'm familiar with, and so I knew that I was going to be listening for incoming messages on a queue or a topic, and so I knew that I could basically execute based on messages coming into that topic, so I did that. Now, the thing about it is, so these Raspberry Pis are just Linux environments. So you can SSH into them, and you can install Python on there, so you could run Python scripts on there. And again, there are libraries for Python for Node.js that allow you to listen yourself on MQTT topics. In the case of IoT Edge, our IoT Edge capabilities, what we're doing is we're simplifying a lot of it, because instead of you having to install all of those libraries and things yourself, which you can do by creating your own image and stuff, but we're packaging that together and giving you kind of a PaaS environment on a Raspberry Pi to deploy artifacts to, and be able to do what you need to do at the edge, right? And just to give you an idea, so this right here, and you can see I am of the hack and slash variety of coder. You can see that I've actually deployed this edge function multiple times. I'm actually going to give you a different view of this. So this is the command line interface that you can utilize in order to deploy one of these functions or container onto the edge device. So it's got G-Cloud Edge, and this is, it's basically part of, if you've used the Google Cloud command line interface before, you do like G-Cloud init, G-Cloud components update, that type of thing. So in this case, it's G-Cloud Edge, and we're using functions. You also have containers there, and you have machine learning. And so in this case, I've got a function, I'm going to deploy it. This is the name of the function, gateway reader. I tell it the architecture, and in this case, my Raspberry Pi is running an ARM architecture. So we support that, we support Windows, other variants of Linux as well, or x86. The region is US Central. The registry is my test registry. The device is the IoT gateway. And here's the source. This is where it was sitting on my Mac. That was the path to the Node.js code that was there. And then the trigger topic is the topic that I'm going to be listening to in the environment on the device itself for messages on which to execute my code. Yep.
So you create a device, and then I see that you have that device IoT Gateway 1.
Yep.
So that's a logical device, right?
Mm-hmm.
So could then a different hardware device still be IoT Gateway 1? So let's say you have the Raspberry Pi and then you have another Raspberry Pi. Could you?
If you re-registered that other Raspberry Pi as IoT Gateway 1. Because here's the thing. This is an API that has a bunch of Python code running behind the scenes. And what it's doing is it's actually taking my location, the registry, and the logical identifier for that device, which gives it the unique ability to identify that device out either through a gateway or directly itself to push that container down. And in the case of IoT Edge, it has to be directly connected to IoT Core in order for us to be able to push those things down.
So how do you register a Raspberry Pi?
Okay, let me show you that. So if we go back to IoT Core, and I go into my registry, I think I made my screen too big. Okay. And I go into devices here, and I can come up here to where it says create a device. All right, so this is where I would put in, so let's say this is my GDG test device 1. I'm really good at naming things. And then basically what I can do is I can decide whether I'm going to allow communication bidirectionally with this device or if I'm going to block it. Then I'm going to put my authentication in here. And in this case, I would upload a key and I would tell it what the format was. So in this case, I could browse on my local box and I could find, you know, a key that I had generated. And again, you can just use OpenSSL to create your RSA private key and then generate a public key off of that. And the public key is what you're going to upload to the IoT repository. Then you have the ability to set metadata. So if you wanted to put attributes in there that uniquely identify the device or attributes that you want sent back and forth with the device, you can create those attributes as you're creating the device itself. And then you have the ability to create logging or set the logging level. So most of the time I put it, sorry, this is way at the bottom. Most of the time I put it on debug because like I said, I'm a hack and slash kind of coder. So I need as much information as possible to know if I'm making mistakes. That's really all you have to do, okay? So that creates the registration. And then from the device itself then, that private key has to be stored somewhere on the device. And in the case of production workloads, that's typically going to be part of the manufacturing process. That private key will be on the board itself, not stored on the file system. So in my case, I just have the private key on the file system itself. So if I go out to one of my devices, oops, I guess you don't need books, or the login. So if I go out here to one of my devices, let's see. So you can see I have it in a really secure place in my home directory. So here's the private key that you're going to use. Now from the device itself, you're going to have an initial configuration that's available for that device to get from the IoT Core because of the registration that you made. The device has to connect to IoT Core once to get that initial configuration down. Then there's a linkage between the device and IoT Core that can be used. And whether it's an IoT Edge device that you're going to push code to, or if it's just an IoT device that's going to be sending data up, that handshake has to happen when that device is created.
So the G-Cloud command you just wrote, that pushes your all the configuration down to the device, right? That makes the link, right? The moment you run that one, right?
Not this one specifically. So there are different, this could be a way that you do it, but there are easier ways that you can just do a simple handshake. It's just a script. We have a script that you can download from a GitHub repo that basically gets that initial configuration down so your device is ready to go. This one actually, so this G-Cloud Edge, what it's doing is it's taking the code from this source tree right here, and it's actually going out to our cloud build service. So if I go out here to cloud build, you'll see that, again, I've done a lot of builds out here, and you'll see that this was my function gateway reader, and it's the latest image of that. So if you go in here, this is what that G-Cloud Edge command did. I packaged up all of that code, I streamed it up to the cloud build service. The cloud build service actually went through, it validated the code, and then it started putting my Docker image together. It put my code base on there, put all the paths the way that I had said I wanted it, based on where my index.js was in my package, what my dependencies were. It'll get so that my node modules will be there so that it's ready to run right away. And then it'll put that together. It'll look at previous images that are out there in my build repositories. It'll take the things that it doesn't need to change out, and it'll change the things that it does, so it builds my image for me, and then it pushes it out to the device. So you can see down here, So you can see out here, it's pushing that image out to the device itself. So now that new code will get refreshed in there, so it kills the old Docker container. So whether it's a function, whether it's a specific custom container that you created, or if it's a TensorFlow model, all of those are going to run in a container. So when you do this push, it's going to kill the container that exists right now and start up a new version based on the push that was just done.
And that connects to the
Yep.
cloud.
Yep.
Is there like a Kubernetes equivalent that will manage all the Docker?
So that's a good question. And I guess the way that I would answer that is most of these devices, they're not going to be like server class type things. So you're not going to have a multitude or even clusters of containers that are down there. They're going to be pretty much very custom to specific actions that you're trying to take. So we don't have Kubernetes there now. It's really just you have the Docker executables that are running, and then you can use, you can shell in, you can SSH into the device itself, and you can execute any of the Docker commands that you normally would, and then you can look at the logs for any running containers and things like that.
And what is the maximum number of such Dockers being deployed on a single machine?
So there's not like a hard and fast limit. It's going to be dependent on how much storage you have and how much memory you have, right? Because at some point you're not going to be able to context switch between a bunch of containers if you have a very constrained memory and CPU footprint there.
Okay, thank you.
Yep. Other questions? All right, so let's look. Okay, so I'm going to jump to the next one. I mean, I can show you the function is deployed out there, and if I go out here, and you'll see that this is going from, if you look up at the top here, this is going from device 2, IoT device 2. So if I set this to test message 3, and I'm going to publish this IP address right here is my gateway. That's where my gateway is running right now. And so if I publish this message over to that MQTT broker, what should happen, again, pray to the demo gods that it actually does. So what should happen is that when we go out here to my IoT registry, and I go back out here to my devices, and I go to device 2, and I go to configuration and state history, there should be a new state that updated at 7:45. And if I look at my text there, it's test message 3. So again, so I've got a collection of fun Raspberry Pis up here. You guys can come and look at the blinking lights and whatnot. But one of these devices published a message to the gateway. The gateway then translated that, and it sent the message on behalf of the other device using its own credentials up. Now, one of the things that I didn't touch on out here. So in this gateway instance, so there's a couple ways that devices can be bound to the gateway here. One is you can bind without authentication or without credential, so that the gateway then is responsible for providing the credential up to Cloud IoT. This could be able to send its own credential. So it may be able to create its own JOT, which could then go along with the request and so it could authenticate directly to IoT Core without the gateway actually having to provision the authentication for that managed device. So those are a couple of different ways that you can authorize or authenticate your device through a gateway. Okay, so the other piece, and this goes back to the question that was asked about like non-Wi-Fi networks or non-TCP/IP networks. So what I did, like I said, is, I have to go to my incognito window. Okay, so this is the UI for Home Assistant, which is basically an open source kind of home automation platform that you can utilize. And again, you don't even need to use any of this because it's all API driven as well. But what you see over here is Z-Wave. And so the one thing that you can see here is I've got this AOTech Z-Stick Gen 5, and it's in the ready position, or it's in the ready state. And then I have this multi-sensor. I have 3 multi-sensors here. 2 of these are initializing, and they're in a cache load state because they're not here with me tonight. And the other one that's here is currently sleeping because it's running on battery. So it has intermittent wake-ups that happen where it will post new data up. And if I go in here, you can get information about it, but this is the device right here. I can lift this up. So this dongle right here is what's actually receiving the Z-Wave messages from the sensors. So this does all the translation for me, and then it syncs into the Home Assistant framework itself so that the messages are able to be translated into something that's usable by me. So if we go out and I take a look at, let's see. That's the gateway. Sorry, here we are. So if I go out here, all right, so this is basically the Z-Wave network, and you'll see that right now the only thing that's showing up here is node 6. That's the only node that I have with me right now. So if I, again, pray to the gods. Okay, so I woke it up, and these are the changes that are going in. So it's refreshing its values, and those values are being read by that stick and converted over and translated into messages that are basically able to be utilized. So I can take some of that information that's coming to me through the USB interface here, and I can package that up, put it onto an MQTT broker, which can then publish a message out to the cloud. And you'll see, let's see. All right, so you can see this is in my system. So the Edge function was executing, and then the MQTT bridge pushed a message up to IoT Cloud or IoT Core from the Edge to IoT Core. So again, as I'm getting these messages, my Edge device is pushing a message up to Core, and if you watch the log long enough, you'll also see things that arrive back from Core, right? You might get an updated config, you might get a ping request, like a heartbeat type message, to make sure that the device itself is up and running. So that's, I mean, kind of what I had, planned to talk about, and what I wanted to do was open it up for anyone to ask questions about anything related to our IoT products or IoT in general, or experiences that you've had if you want to share with the rest of the group. Yeah, go ahead.
I'm interested in how low latency you can get. Suppose you're cell connected, and you had to send and get a response back. What kind of latency could I expect?
So that's a really interesting question, and there's a lot of different ways that you can approach that. So one of the things that I can talk about is, so Google's cloud platform utilizes the same infrastructure that our Google consumer services utilize. So in that case, what you're talking about is all of the POPs, the points of presence that we have around the globe, which are basically on-ramps into the Google privately owned fiber optic network. Basically, your cell signal could jump onto the Google network, reduce latency because it's using our premium tier networking. But I mean, without proximity through your ISP to one of our on-ramps, but usually you're like one or at worst 2 hops away from actually getting onto the fiber optic network. So I couldn't give you a hard and fast rule, but what I can say is your latencies are probably going to be lower than most other providers. Yes?
Is the API spec for IoT Edge available yet, or is that part of the click here for access?
It's part of the click here for access, right? So it's in early access and technically it's in alpha. So basically for it to go from alpha to beta, it has to stay stable for a certain amount of time before we'll move it to beta. Once it goes to beta, that's when it's going to become available to the general public. But we can certainly work with you to get you whitelisted as well.
How does this relate to Android Things, which seems to architecturally fit in precisely the same spot?
Okay. I was wondering when this question was going to come up. So, yeah, so you know how Google has like 6 different messaging platforms? Okay, so Android Things, there's been a bit of a change in strategy with Android Things. So Android Things will continue to be a development framework that you can utilize. So it's not like we're going to take away the images that are out there that you can, flash onto an SD card and put it into a Raspberry Pi and utilize it that way, right? But right now, from a commercial perspective, Android Things is focusing on partner relationships. So if you see things like Samsung smart TVs, some of the smart speakers that are out there that are using Google Assistant technology that are not Google Homes, those are utilizing Android Things. And that's kind of the direction that we're going right now with Android Things. And believe me, I was a little put out by that myself because I built up a lot of good proximity demos, like using our proximity libraries and Bluetooth beacons and things like that, because they have an incredible support for that in Android Things, which if you've done it on Linux platforms, it takes a lot more custom configuration.
Yeah, I have a lot of Bluetooth beacons too.
Yeah, and so like Android Things was such a great platform for anything that you wanted to do with kind of physical locations and proximity locations. But yeah, for right now, it's kind of in flux too. Like the strategy is not well defined even for us internally. But what I can say from a public perspective is that the focus right now is OEM partnerships with things like smart speakers and smart TVs. Unfortunately. Other questions? Thoughts? Was it interesting? Did you learn something?
Oh, yeah.
Well, that's good. Yeah, and I'm hopefully gonna kind of perfect this because this is kind of the genesis of what my talk at DevFest is gonna be. So I'm gonna be covering IoT there as well.
Is your job largely IoT focused?
Actually, it's not. So my job is across all of the GCP portfolio, and of course, everyone is gonna have their own areas where they're more interested. So IoT is a particular interest of mine, so I have spent a lot of time doing it. It's also potentially a place where I might jump off to in another role within Google, right? So it's of interest to me, and there are other people who are very interested in machine learning and things like that. So everybody gravitates to things that are interesting to them, and we didn't even get into, okay, this was your on-ramp to getting data into the cloud. We didn't even touch what we can do with the data once it's on the cloud, right? And so, that's a whole nother topic to explore in terms of visualization, data analytics, machine learning. There's a ton of stuff. So IoT, the mechanics of getting the information from the device into the cloud, that's like barely a tenth of what is really there to discuss about how IoT is actually valuable.
So if I'm interested, for instance, in speech separation or enhancement, which is my area of interest, I assume that there are models available and so on that already are already created and tested, and potentially I could take an IoT device and find my way have an inference download that's going to.
Yeah, so Google has, I don't know, half a dozen pre-trained models that you're able to utilize. And those pre-trained models go from like individual images to video analysis to speech recognition. So it can do either translation or it might do speech to text.
Are these models, what if I want to improve the model?
What if you want to improve it? So that's where we have a product called AutoML. So what AutoML does is you take the pre-trained models of Google, you provide your own training sets for it, and you modify what's actually happening. You don't want to change it.
I want to change the model.
Change the model. So the models aren't published from that perspective, as far as I know, right?
Say are not published?
Not publicly, as far as I know. Ripka, do you know?
Depends upon what you mean by change the model.
I may want to add layers, I may want to change it.
I mean, so that's where you get into transfer learning. And so you can take our base models, and you can go down a couple layers and then transfer learn from there. And so that's what the purpose of transfer learning is, which is take a model that may be very basic in its initial form. And so that's more of an open source kind of a conversation where all of our models that we actually build on top of and train with our masses of data, we actually built as very basic transfer learning models with publicly available sets.
Okay.
Last call for questions.
So how is the market share for Google IoT? It's still in alpha beta stage, right? So it's not
So IoT Core itself is generally available and has been for over a year. So we do have some customers that are using it, and some rather large use cases as well. Again, the IoT space, very fragmented right now. And it's often predicated on who your device manufacturer is, because they'll typically have some sort of framework as well. So I do think that people are wanting to do a little bit more roll your own with things. So I think some of the major cloud vendors like ourselves, AWS and Microsoft, all have really compelling IoT cases. I would say that ours has become more compelling since we've added edge capabilities, because when we were just sitting with IoT Core, it's not as compelling, right? It's very limited in the use cases that you could take a look at, and so it's certainly gotten better. But I think that's the case with almost any of our Google services, right? We were lagging behind AWS, right? AWS was first to the market, and Microsoft, came charging after it, and Google had small numbers of services, and over the last 2 or 3 years, we've dramatically increased our coverage in terms of infrastructure as a service, platform as a service, and even software as a service. God, that sounded a little marketing-ish. Sorry. Yeah?
So the 802.15b frequency, is that something that goes through barriers better or better range, or why that frequency?
It really has more to do with the simplicity with which you can set up a mesh network, and kind of the specification for having controllers, routers, and then end devices. So from a mesh perspective, again, if you look at, like say, let's talk about actual use cases and not just sensors in my home, right? So let's talk about a shop floor where you want to do maybe some predictive maintenance on your shop floors. So maybe you have thousands of sensors that are monitoring vibration in the machines that are actually doing the manufacturing. And based on that, even if you wanted to do a gateway, like if you were doing a traditional kind of wireless gateway, you would start to saturate your bandwidth there. But because this is more of like a point-to-point network, it really works well for large numbers of devices communicating over short distances. So it is very much purpose-built for these types of utilizations. It's definitely not for long-range communication. So that's kind of what it does. And it does well going through a lot of different substrate levels, but it's not as powerful as other radio frequencies. All right, if we are done with questions, we have a couple of giveaways here.
It's not signed in.
Yeah, did anyone not sign in at the front table? All right, add your name. Everyone is eligible, even if you're a coordinator. There's nobody that's ineligible. I got one back there that wants to sign in.
All right.
Put your name on the back of this.
So open a browser.
Oh God. Are you gonna make me do something hard?
No, this is actually how easy it is.
Was that what you were researching during the talk?
No.
Of course.
Okay, where am I going?
Just take it.
That's the other.
Oh.
So, until when everybody gets signed in,
Then you'll give me the max?
I thought you had to buy one. Thank you.
Is anyone else not signed in?
Yep.
Going once, going twice.
All right, so the first two are judges ruling based on questions, interest, and level of engagement. So have a water bottle. And thank you for your attendance and participation. Like I said, I hope it was instructive and makes you wanna experiment.
I have 26 as being the maximum.
26?
Yeah.
All right, and the first winner is 21.
That looks like Jason from Data Stacks.
And you are an owner of an Android Things dev kit, so you might want to just reflash that to Linux or. Oh wait, I gotta do it again?
Refresh again.
Do I have to refresh or can I just generate?
Just generate again.
20. Wow, wait, that seems like,
Oh.
no, I can't do that.
redo it again.
I can't do that.
So, Terrence?
There you go. Thanks, everybody.
You can't do that on the live stream.
No, we don't want to give it to number 20. Oh, wait, I can turn this on.
There we go. Thanks everyone for coming. We've got a few more minutes in the space and then the carpet gets rolled up. So.
Yeah, if you still have questions that you want to ask, feel free to come up and